In this video, we'll be covering the first lesson of the second unit. So the big focus, the second chapter, is arguably to factor a cubic, or in fact any degree of greater than 2, because you're great at factoring quadratics already. And you even have a quadratic form to help you out. But what you're not really good at is factoring a cubic, or quartic, or quintic. So why would we want to factor a cubic? Because in the previous unit, you were given polynomials in factored form. In fact, you were hardly ever given polynomials in standard form and asked to graph, okay? And if we did give it to you, it was because it was factorable using your grade 10 techniques. And you can't do the word problems in this unit without being able to factor cubics. So the first two lessons is just to build up your algebraic skills and enable you to factor cubics. And from then on, you'll be able to tackle the big ideas like the word problems and so forth and so on. So the first two lessons enable you to factor cubic. So we're going to start off by talking about remainder theorem. But before we get to remainder theorem, we're just going to quickly review long division. Okay, and you did this in elementary school, and it's been a while since you've last done it probably, but I just want to go over the key numbers when we talk about long division. So the number you're dividing by, right here, 993, that's your dividend. Okay, what you're dividing by, which in this case is 12, is called the divisor. The answer you get is called the quotient. And lastly, if 12 is not a factor of 993, you're going to get a remainder which is not 0. So in this case, the remainder is 9, so I know 12 is not a factor of 993. For example, like I know 3 is a factor of 6 because 6 divided by 3 has a remainder of 0. It's just 2. Okay, so if I had 993 cookies and divided between 12 people, we're not going to share very nicely. Well, you're going to have to end up breaking a cookie. But we're going to just take 7,877 and divide it by 3. And believe me, this is going to come in handy when we try to factor cubics. Okay, this is our first step to help us factor in cubics. Okay, so 7,877 divided by 3. So how many times can 3 go into 7? And the answer is 2 times. And then 3 times 2, you multiply, you subtract, and you bring down the next place value. So 3 times 6, so we can go into 18 6 times, subtract, bring down the next number, 7. How many times can 3 go into 7? The answer is 2 times, subtract, bring down the next value, and then 3 can go into 17 5 times, subtract. You can't go any further, and there's no other number to bring down, so guess what? 2 is our remainder. And you can check your calculation, you can check your long division to see if you've done it correctly. Okay, because we have something down here to help you remember, but you should have learned this in elementary school. The divisor times the quotient plus the remainder is equal to the dividend. Okay, so I'll write down why that makes sense. So 7,877 divided by 3 can also be written like this. Okay, when you see this, you think of an improper fraction, and because the quotient is 2,625 and the remainder is 2, okay, and divisor is 3, you can rewrite it like this. What is this? Like I said, 7,877 over 3, that's an improper fraction. And 2,625 and 2/3, that's our mixed fraction. Okay, so if I multiply both sides by 3, I will get what I wrote at the bottom of the page, right? If you multiply both sides by 3, and by the way, there's an operation here, 2,625 and 2/3, that's plus 2/3. So 7,877 is equal to 2,625 times 3 plus 2, right? Because this 2,625 and 2/3 is 2,625 plus 2/3. Okay, it's not multiply, it's plus. If I ate 1.5 cookies, that's 1 plus half. It's not 1 times half. Okay, so there you go. This proves what we wrote at the bottom of the page, that your divisor times your quotient, or your quotient times your divisor, plus the remainder is equal to the dividend. That's based on your logic from going from an improper fraction to a mixed fraction. Okay, so we're not going to divide real numbers using long division anymore. What we're going to do is divide a polynomial by a polynomial, but we're still going to use long division. Okay, so in this case, x squared plus 5x plus 7, that's our dividend. And what's our divisor? Our divisor is x plus 2. So I know it looks a little different, but the strategy is still the same. So what do I have to multiply x by to get to x squared? Well, x times x will give me x squared. I'm going to put x right here. You want to line up the like terms to keep it organized. So now that I know I have to multiply x by x to get x squared, I'm going to actually multiply it. Okay? And then I'm going to subtract, just like before. And I put a bracket here just so I don't confuse this as the coefficient of the x squared term. Okay? So 5x minus 2x is 3x. This is 0. Has to be 0 here. Okay? Otherwise, you didn't do it correctly. And you bring down the next term, just very similar to what you did with long division of real numbers. Okay? Now what do? I multiply, just like before. So what do I have to multiply x to get to 3x? And the answer is 3. And then 3 times 2x, subtract 1. So there's no other term here for me to bring down, okay? And the degree of what I have here is 0. And the degree of what I have here is 1, okay? So this means I cannot keep progressing with this long division. So if that's the case, guess what? 1 is the remainder, and x plus 3 is our quotient. Now, after you're done the long division, you may be asked to do one of two things. Express your answer in quotient form, which is what we said on the first page, which is going from an improper fraction to a mixed fraction. Or you can express your answer as a division statement, which is the same statement that allows you to check your answer. So your polynomial or your dividend is equal to the quotient times the divisor plus the remainder. And as I said before, the degree of the remainder must be less than that of the divisor. Because if it's not less than that of the divisor, you can keep going. You can keep going in your long division process. So it has to be less than. All right, so let's practice. So for example 2, it's in quotient form. Example 3, we're going to express it as a division statement. But in both cases, we just have to long divide. Now, my dividend in this case is missing the x squared term, so I'm going to put a placeholder, 0x squared. All right, let's do it. So what if to multiply 2x by to get to 4x cubed, and it's 2x squared. And then I'm going to multiply, so 4x cubed, and then 1 times 2x squared is 2x squared. Subtract negative 2x squared, bring down the 9x. And then what if to multiply 2x to get to negative 2x is negative, sorry, what if to multiply 2x by to get to negative 2x squared, and that's negative x. So that's negative 2x squared, beautiful, minus x. Subtract, be careful. Here, this is 9x minus negative 1x, okay? Minus minus is plus, so it's 10x minus 12. Now, what do I have to multiply 2x by to get to 10x? And the answer is 5. So 10x, 5 times 1 is 5. Subtract. So negative 12 minus 5 is negative 17. Beautiful. So that's expressed in quotient form. So quotient form means improper to mixed. So 4x cubed plus 9x minus 12 over 2x plus 1 is equal to 2x squared minus x plus 5 minus 17 over what's our divisor? 2x plus 1. Okay, and when we write it in quotient form, we add a restriction, because we can't let 2x plus 1 in this, if you look at the statement, we can't let 2x plus 1 equal 0, correct? Because it's in the denominator, so we say x cannot be equal to negative 1/2. Okay? So there you go. That's in quotient form. Dividend over divisor equals to quotient plus remainder over divisor. Since your remainder is negative, it's a minus here. But try not to memorize it. Really think about what you did before, which is improper fraction, mixed fraction. And you keep it simple. Okay? All right. So now we have one more. We have this one. We have to divide it. X cubed plus 7x squared plus 14x plus 9. Okay, and then we have x plus 2. So x squared, x times x squared is x cubed, and then 2x squared, and then subtract 5x squared, and then bring down the next term, 14x plus 5x, so that's 5x squared, plus, or so times 2 is 10x, subtract 4x plus 9, and then plus 4x plus 8, subtract. I can't go any further because the degree is lesser than the degree of the divisor, so this 1 must be the remainder. Now they want us to express the answer as a division statement, no problem. So x cubed plus 7x squared plus 14x plus 9 must be equal to x plus 2 times x squared plus 5x plus 4 plus 1. So just like how you were checking your answer with real numbers, you can actually check your number with the polynomials. You can just expand the right hand side, multiply the binomial, trinomial, and then add by 1. Okay? All right. Okay, so we really don't want to do all this division, to be honest with you. Okay? We are actually interested in the remainder, but we don't want to use long division. Okay? So we're going to try our best to find a shortcut. So let's look at these two examples, and hopefully by doing these two examples, we'll see a pattern and we'll generate a shortcut, and then we'll have to prove the shortcut. Okay, so find the remainder when you divide x squared plus 3x by x plus 1. Okay, let's do that. So unfortunately, we gotta do a few more reps of long division, but since you're first learning how to do it, the extra repetition is great practice for you. Okay, and then x. Okay, x times 2 will give me 2x. Be careful, negative 2. 0 minus 2, negative 2. Okay, so the remainder is negative 2. Now, like I said, I really want to find the remainder without doing all this work. So I ask you then, find p of negative 1 if p of x equals x squared plus 3x. Okay, let's try. P of negative 1 equals negative 1 squared plus 3 times negative 1. So this is 1 minus 3. Hey, negative 2. Interesting. Okay, let's keep going. But before I do that, I just want you to take a look. P of x is x squared plus 3x. Where else did you see x squared plus 3x? I'll let you think about that. And if you're ready, you can try 4. Oh, sorry, 5. Okay, so I divide 2x cubed plus x squared minus 3x minus 6 by 2x minus 3. Okay, all right. So 2x cubed plus x squared minus 3x minus 6. And the divisor is 2x minus 3. Okay, so I'm going to multiply by x squared, right? 2x times x squared is 2x cubed minus 3x squared. So this is going to give me 4x squared. Be careful. 1 minus negative 3, 4. Okay, and then I multiply by 2x. 2x times 2x is 4x squared. Beautiful. Negative 6x. Okay, negative 3x minus 6. So it's basically negative 3 plus 6, which is 3x. Bring down the next term, negative 6. Okay, let's keep going. Ooh, this one's a little tricky. 2x times what will give me 3x? So if you think about it, let's see, how about 3 over 2, right? I know it's unconventional, but try it out. 2 times 3 over 2, that's 3. 2 times 3 over 2 is 3, so that's going to be 3x. Now here, just negative 3 times 3 over 2 is negative 9 over 2. Okay, so you can use your calculator, but this is basically 4.5. So negative 6 plus 4.5 will be 1.5. So it's negative 1.5. So negative 3 over 2. Okay, now that was a lot of work. Like I said, I really don't want to do all this long division to find the remainder. It would be really nice to be able to find the remainder without doing all this long division. Oh, hey, let's find p of 3 over 2 if p of x is equal to 2x cubed plus x squared minus 3x minus 6. Hey, wait a minute. This is exactly the same as the dividend. Okay. So it seems like we're getting somewhere. You know what? You can punch in your calculator, but it is equal to negative 3 over 2. So I usually give my students like good 5-10 minutes, or 5 minutes should be enough, and they see a pattern and they discuss the pattern. So you can take your time and try to see a pattern. So pause the video and we'll have a chat later. Okay, so hopefully you've noticed that this 3 over 2 didn't come out of nowhere. Okay, first of all, I already told you that p of x is your dividend. Okay, but this 3 over 2, I didn't just randomly pick that number. I picked 3 over 2 because it has a relationship between the divisor, or with the divisor. The divisor is 2x minus 3, and I chose 3 over 2. And for the first one, example 4, I chose negative 1 when the divisor was x plus 1. Okay, so hopefully you realize that the value I chose makes my divisor, if I evaluate that at that value of x, it makes my divisor equal to 0. Okay, so that wasn't coincidence, and actually on purpose. So if it makes a divisor equal to 0, you're able to evaluate and determine the remainder. So this is the shortcut. So let's I won't fill in the last line here, because the last line here is actually what I wrote on the next page. Okay, what I want you to get to is called the remainder theorem. The remainder theorem is basically what we wanted to do from the get-go, which is find the remainder without doing long division. Find the remainder without doing long division. So how can you find the remainder without doing long division? Like I said before, so I have a polynomial p of x. It's divided by x minus b. Okay, if I divide by x minus b, the remainder is p of b. Okay, that's analogous to what we did for example 4. Now, when p of x is divided by ax minus b, the remainder is the same as p of b over a. Remember, b over a, if I sub it in for x, that would make ax minus b equal to 0. And of course, a can't be 0 because then b over a would be undefined. Okay, so that's the remainder theorem. It allows us to find the remainder without doing long division. So now we have several questions. Okay, the first one being, how does the remainder theorem work? Okay, it's great that I told you that this is true, but how does it work? And secondly, why do I care about the remainder? Right? Why do I care about the remainder? So let's answer the first question. How does it work? So it works because p of x is your polynomial, but it's also your dividend. If I wrote the division statement, okay, it would be equal to q of x times And let's say the factor is x minus b, okay? We could do the other one in a second, ax minus b. Let's say it's x minus b. And if I divide by x minus b, I know my remainder will be a constant because the divisor has a degree of 1, which means my remainder has to be a constant term, has to be a degree of 0. So let's say it's r. So what makes x minus b equal 0 if x were to be b? So let's find p of b. Let's prove that p of b is actually the remainder. So it's equal to q of b times b minus b plus r, and b minus b is 0, and 0 times anything is 0, so p of b is equal to r. Perfect. Exactly what I wanted to prove, because that's exactly what the first line is saying in the remainder theorem here. And what if your divisor is ax minus b? Oh, no problem. Okay, ax minus b, so p of b over a a times b over a minus b plus r, and you will get p of b over a is equal to r. Okay, oops, sorry. So p of b over a is equal to r. So let's start from the beginning here. So you have quotient times the divisor plus the remainder. This is the division statement, okay? If I evaluate at b over a, then I will get the remainder from the long division if I were to divide by ax minus b. Okay, you want to make the divisor equal to 0, because if you look at the division statement, that will basically leave you with the remainder. Okay? Okay, so that hopefully answers our first question. Okay, the remainder theorem can be proven from the division statement. So that answers our first question as to how does the remainder theorem work. Now for the second question, why do we bother caring about the remainder? Okay, why do we care about the remainder? Let's see. Now that we have finished the lesson, why do you think it is necessary to learn how to divide a polynomial by a binomial? Okay, so what I'm trying to say here is, remember, what is the end goal? What was the thing I said in the beginning of the lesson? I said our goal is to factor a cubic. Okay, so we're getting actually really, really close. Okay, to be honest with you, we don't really care about the remainder. We only care about the remainder if it's equal to 0. Okay, why do we care? I kind of dropped the hint in the beginning on the first page too. We only care about the remainder if it's 0, because that will tell you your divisor is a factor. And what are we trying to do? We're trying to factor a cubic or a quartic or a quintic. So that's why we introduced with remainder theorem, because that is in a sense it's going to help us find the factors of a cubic. Okay, so to be honest with you, we really don't care about remainders unless it's equal to 0. Okay, so we'll continue this discussion in the next lesson.